So what are we doing today? I'm not quite sure, but I think we have we've got a rather sentimental thing to do. This one is a bear that belongs to my wife. And she's had it quite a long time, most of her life in fact. And at some point it got drowned through no fault of her own, and stopped playing Brahms' Lullaby. And there is a little voice box in here. We have not been able to find the make and manufacturer of this, and the tag was removed at one point so that she could take that with her. The tag thing was kind of a memento thing, just so she didn't have to carry the teddy bear everywhere. It got attached to a bracelet, I believe. Now, at some point, the batteries went flat, and it has had some expert stitching from a beloved late grandmother as well. So I'm going to have to be very, very careful, because we don't really want to mess up the stitching from the hand of the late grandmother. So yeah, we are going to have to get this module out somehow. And the module is, if I put my fingers on the edge of it, is about that big, and it feels very flat. If I can turn it sideways here, we can see it's about that thick. I dare say it will be using a button cell battery like a CR2035, but I'm curious to know as to what technology is in here and whether or not I can resurrect it, because this is around about the era, what was it? It would have been around about very early 90s when this was in vogue. So in fact, probably a little earlier than that. At that point in time, there was a whole host of things. I think it's when the magic blobs came out first. They had a microchip and it was just under a blob of resin. There were also chips produced that were attached to boards with no resin coating whatsoever, and others that came in the full resin packages with legs. So I'm not sure what to expect in here, but I'm going to have to do some very delicate surgery here. So I'm going to try and employ all the tools I've got. For a start, I'm going to get my quick unpick here and see if I can do something about this stitching without causing any further damage to this. Now, this might not be a shortbread tin, but it's an identical style of tin, and I've got several of these. Oh, I thought I didn't have any white thread, but I tell a lie, I do. I've got a bobbin full of it. That will be handy. Now in here I have a special tool somewhere. And no shortbreads or chocolates, unfortunately. Wouldn't mind a couple of them right now. Here we go. In amongst all my prototype cams for the Singer sewing machine, I have a quick unpick tool for undoing threads. Alright. Now I've had a good long think about this, and I've come up with a plan of attack. I think I'm going to just undo this very short section here, and not all the way around the legs. This look like what has been done before, and I hope I'll be able to get it out from there. I'm only going to do as much as is necessary, because it's delicate, it's old, and we're looking right between its legs. So yeah, I've got to give this bear a hysterectomy now. Taking a slightly different angle here, just for convenience sake, because I really can't afford to mess this up. So I'm just going to pick up one thread as carefully as I can, and this thing's got loose inside the handle. You know what, I'm going to fix my tools first, and then I'll do this work. Alright, so a little bit of hot glue later, because I've run out of super glue. Completely out, that's a rarity. But alright, let's get back to this now. Not sure what this extra thread here is for. I think it's used a rug stitch, and they've run that as a reinforcing up underneath all the others. I think that's how that's been done. Okay, there goes one. Let's see if we can pull this through. I guess not. We'll just have to undo each stitch one at a time. This is delicate work, and I'm taking my time because I only have one shot at this and I cannot afford to fuck that up. And yes, that was some profanity, but this is not a monetized channel, so I don't care all that much. Right. Now there's a second stitch along there. Just move along very carefully here. Just taking my time. This actually reminds me of working on hearing aids. Very similar sort of work here. Although I was working under a stereoscopic microscope on stuff far smaller than this. Something I don't quite have the dexterity for anymore. Alright, here we go. Here's our other thread here. Let's come out. That thread might actually be attached to the unit itself, possibly. Now, I don't want to undo any more stitching. I'm going to see if I can manipulate this out from here. There's some stuffing in here. If I can get my finger underneath the stuffing, I can compact that down a bit and try and slide this unit along. I'll use the back end of this to try and guide it up and over the stuffing. If we can get this out. Right, we might cut this here and I'll get back to a moment and we'll update you on where I'm at. Okay, so looks like it's about to give birth here, but if you can probably see down here a little bit, there is some purple fabric over the top of the unit itself. It's a bit hard from this angle, but I'm not going to get it out that gap as I thought. So I'm going to have to go up one leg a little bit, and I had a bit of a plan ahead of time about this. There is some stitching down there too. I don't really want to cut that, but it's a bit of a rock and a hard place here. This is some fairly hefty thread in here. It looks almost like wax thread, which means I'll probably have to find something similar to stitch this back up again. But alright, it's about as far as I want to go with that. I'm just doing a couple of stitches at a time. So if we can manipulate this up here, we can see the purple bag that's in there. I'm going to try and rotate this sideways to make it move along a little easier. See if we can get this out. I'm being gentle because I don't want to rip anything. But this bag feels like it is actually attached to something to keep it located in the center of the belly. Here we go. And the bag has been opened before. Alright. And I think there was reports of it having had a battery change in the past. So this is going to be a tight squeeze. But this little bag is not the end of the world. This is not really a cosmetic bit of it that we're too worried about. It's just there to locate it. So we might just open that up a tiny little bit just in here, just to help get that out a little bit. Alright. Oh, we're almost free. With minimal stitching loss. Here we go. Alright. That's our voice unit. And I see a piezo speaker in there. And it looks to be molded and it looks to be very fragile. Oh, this is going to be fun. Okay. Now I think the anesthetic's still taking effect, so he can snooze over there. Ooh, I don't like my chances of getting this open intact. Definitely feels like there's a bit of foam under there. It's certainly not designed to be waterproof. I'm going to spend a bit of time looking at this and thinking about it first. Alright, so I've got the microscope out here. I'm going to fire this up for a minute. Where are we? And get my focus in position here. We want to do that. Alright, now I need to start the recording here. And we'll go. I need something to synchronize these two bits of footage, so I'm going to go. Right, that'll give me enough to synchronize it. Okay, what we want to do here, now that we're looking at the footage on the side of the screen, now we want to see this join here. I was concerned that this glue was glued, but looking at this, it might not be. Apparently, my wife's father changed the battery in this at some point, which leads to thinking that it is possible. I'm not seeing any glue here. I am seeing a sign there that it was prized open. If we get a pointer here, this bit here seems to indicate that something was prized that open. I'm thinking a scalpel blade might do it, but maybe even this might fit in the gap. That's a little too big to do the job there. So I think I might get a blade or something. You know what, I actually have just a thing over here. If I'm careful, I have a Victorinox, or Victorinox, however you pronounce that, Swiss Army knife, and it's got a very nice fine blade on it. Where are we here? We might be able to just insert that in that gap and pop that open a little bit. Now I can use something a little bigger, and we can push into this gap here and open that up. Yeah, I think I can work my way around that for now. Alright, I'll continue with the knife blade, and we should hopefully get that out. Where are we? Continue this way, hopefully without cutting myself. I'm just rolling, and I'm just levering gently with the knife, ever so gently, because these are wildly sharp ones. And there's little bits of whisker in here too. I think maybe somebody had just shaved their beard when they last worked on this. Alright, I think we are open. Alright, there's a top half over the side here. Let's tip this out. Aha! Okay, here's our little rubber pad. Okay, this is good news. This is actually very good news indeed. This is a magic blob. It's a microchip under a blob of resin. Now I'm not liking all of this corrosion right up close here, but these batteries I've probably got some of, and it's actually got a name on here. Right. Well, that was a blob of blue tack falling off my desk. I normally stick them up above my desk to hold stuff on. Of course, when they fall on the floor, they get covered in crap. Now, I seem to recall a 3D printer filament company that's called Ararum. But anyway, these battery holders are definitely going to need some work. And it is a piezo speaker, and that contact looks alright. Let's refocus here. Alright, and there's definitely some fluff in here. What I was thinking might have been whiskers, might actually be part of the threads that they've used in there. Oh, this has got a nasty layer of corrosion and junk on it too, up under here. So look, this might be retrievable. And I know these little membrane pad things, this one's as hard as rubber, like as crap. I've got little rubber contacts, and I can probably put a piece of foam in there and a rubber contact to do that, or I can rob one of them out of something else. Overall, this doesn't look too bad. Let's pop these batteries out. Pop that out, and these little quick unpick tools are bloody handy for everything. Let's pop both of these out. Looks like there's been a bit of corrosion. Oh, here we go. So, battery, where are we? So, Vinic, okay, quality batteries. In the watch cell, so 192 size. What about this one here? Yep, both the same ones. Let's have a look at the seal, see if that's intact still. No. This is the one that didn't like things. Yeah, it's a bit shagged around the edge. Let's have a tip this up. Yeah, this is the one that had most of the moisture damage. Surprised they've fared as well as they have. Alright, so our main approach is going to be these bits here, which we're going to have to clean off. So I think I'm going to get some contact cleaner into this. It could be a new piezo speaker. I might need to lift this off the backing, and it looks like it's glued in. But yeah, we'll try it out first without removing that backing, and then we'll go from there. Okay, now I'm going to turn on my microscope here, somewhere about, where's my record button? Right. You'll hear my apprentice probably throwing a tantrum in the background as it's bedtime and it's a school night. So I've got some of this stuff here that you can probably see up close. It's a contact cleaning solvent made by Servasol. I'm going to start just with a bit of this and let it sit for a moment. And then I'm going to give things a little bit of a scrub up here. I'm just going to do that several times until the corrosion's off. Although this stuff, it works pretty well like magic. It's great stuff. My greatest concern is over here near the chip. And I just want to make sure that that is the cleanest area there. Again, I'm going to use my quick unpick because these things are magic. And I'm going to have a quick go here through the microscope, just trying to clean up any potential corrosion between these tracks here. It looks pretty good. It's down to the fiberglass there. I don't think much got under there. A lot of this looks like it's leftover solder mask by the look of things, or a bit of resin. Maybe a bit of solder flux. This actually looks pretty good now that I've given it that cleanup. I think the batteries might have been close to being flat when this thing was drowned anyway. This could survive reasonably well. Now, one of these battery terminals is kind of shagged, but we really want to find a way to test this. So how are these terminals connected? All right, let's take a look here. So there's a pad under each one that goes to a track. So the pad here goes along that track, and then this track here leads to that terminal. So what have we got here? This is the positive terminal, and it runs along under the edge of the resin here, around and up to the pad under there. So that's a series connection. So that means we're running probably 3 volts. That goes to the pad, that goes under there. So that there would be our positive in. I'm going to mark that on the board actually, under the microscope here. So that is our positive right there. That probably can't see it real well. I'm being very gentle with the board. That's our positive in there. I've noticed that there's some corrosion has come back here. So that will need a bit more of a clean in a minute. I'll use something a little harsher for that. So a positive is going in there. Now a negative, I'm going to assume, comes from across the other side of the board here. So negative will be coming from that track right there. So this is our negative going in there, goes directly into the chip. Well, it wouldn't go very many other places. So that's our negative there. So I want to try and hook this up to a temporary power supply and see if it will work at 3 volts. But first I need to clean that up. So let's see if I can do that with this bit. I'm going to rotate this around where I can see it a little better. And we're going to give this a bit of a scrub. Well, that's coming off very easy. I think that might be on top of some... Well, no, that wouldn't be solder mask on here because this is designed to contact the carbonized pad. This is working relatively well. I'm liking how this is going. Yeah, we'll loosen all this stuff up and we'll get some more cleaner on there. So there's a bit of a film happening here. I see what's going on. That could make that a little difficult. A bit later I'm going to get a little carbonized rubber pad and stick it to the end of a hot glue stick, and that'll make my temporary test button for triggering this. I bet you my wife will come running when she hears it. Yeah, let's give this a bit more service hole, and then we might choose something a little bit, just a tiny bit harsher to help scrub this stuff out. Normally I wouldn't spend this much effort on something like this, but this one has the sentimental value that warrants it. I'm not sure I really need to worry too much about these tracks up here. They look pretty good, and I'm not in an ideal position to do this. The tracks all seem intact, nothing's really eaten itself away, and they look like they're all tinned tracks. You don't see tinned tracks all that often these days, not in stuff that's this cheap. This probably wasn't cheap in the day anyway. Now, alright, this might be at a state where I can at least check it. I'm going to unstick all the blue tack off the bottom of this. I want to know if that piezo works, or if indeed if any of this works. Now, I've got Servicol stuck all over my microscope deck here. So, you don't say deck with a New Zealand accent either. That leads to things like some embarrassing ads I've seen. Right, and yeah, Servicol is one of the few things I found that actually dissolves blue tack. It's quite ugly stuff. So, how are we going to go about this? Let's move it up a little bit so we can get some clips on things. We need to do some preparation, so let's refocus this. Let's do some preparation and come right back. Alright, so one thing I was a little worried about is this piezo element would be getting full of water and rusting inside, but we're lucky and it's a sealed one. But of great concern to me here are these two contacts, and I'm going to have to peel this bit of tape off here and see just how bad they are under there. This is actually looking really promising so far. This is not too bad. I'm going to give this a scrub, but I'm going to remove this blue tack because it's stuck all over me. And I've got that little bit of tape, has got an amazing amount of stick for something that's as old as this. So let's refocus this here. I'm going to give it a little squirt of cleaning solution. We're going to give it a good scrub with a toothbrush. And you'll notice I've shortened the bristles on the toothbrush because it helps me get a little bit more brushing force in here. So what I'm most interested in is the insulation between these two layers, which is this bit here. If that's compromised, then a piezo won't work. But that being said, these things are pretty easy to find. I've probably got a million noisy kids toys out the back that my apprentice has long since lost interest in, that would probably have one of these in it that I can replace. So we're going to give this a good scrape. It's coming up looking rather good actually. I'll leave it all dry. Alright, now while we've been doing this, my soldering iron has been heating up, and you might get a little concerned about that. Don't be, I have a plan, and I kind of know what I'm doing. So what I'm doing off camera here is I'm taking two bits of wire here and I'm just stripping the ends, and very shortly I will tin them, and I'm going to attach somewhere along that circuit to try and power it. So where are we? I'm thinking if I can do this off 3 volts, I might actually use this method to attach a bigger battery, like a 232 or something like that. And there's my extraction fan, there's my outlet fan. We'll bring that all around to where it picks up the fumes. If I put a 232 in there, I might get much more life out of this and limit the amount of times we have to open this thing up again in the future. But I'm going to feed this 3 volts off a variable supply with the current turned right down to almost nothing, so that I don't risk any further corrosion. So we'll get this all in here. If you want to see solder under a microscope, here we go. There's solder under a microscope. And that's solder with no flux in it. After I picked on Tinkerman Mick in private messaging about that a while ago. Alright, now, let's drop this down here. Now, I did mark these. What did I mark? Now, that one is going into there. That's our positive right there. So that one is right there. Where are we? I need to be just double sure of this. So let's hold that down there. That is being held loosely in position. We want a smidgen more blue tack. Okay. Now let's just, you know what, actually, I might fire up the tiny iron for this. Oh no, that one's a big enough contact. We should be right. Okay. We'll do this. I shouldn't be second guessing myself with stuff like this. Alright, we'll just reflow that join a little bit. Now that, I believe, was our positive, so I'm just going to temporarily tack a wire on the side here, and that is a little cold. Let's warm that up a bit. Just tack that wire in there. Then we're going to find a way to drop into the negative side of things. This could be a little... oh, that was hot. I should have known that. This could be a little trickier to try and figure out how to get onto that negative line. So let's go over to a battery holder there. So where I want to get into is this one right here. And I don't want to lose a track, and I don't want to damage the original battery holder. So we're going to just try real careful to just, and I don't want to overhit the chip either. I'm thinking it might be easier just to go off the original pad in here. It's in under there. This is going to be a tricky job. I'm going to turn my microscope sideways here, and let's refocus so you can see what we're doing. Right. I'm going to try and tack in on the original pad. Just ever so slightly on the corner. I'll take the green wire here. At some point I'll probably lift these battery holders off to clean them anyway. Alright, so we've got our ground wire hooked up in there. So let's go and prep our fake button. Okay, so here's a trick that I use for testing remote controls. I have these remote control repair kit here, and these are little carbonized rubber pads. They don't stick to a lot of things, but they do sort of stick to hot glue. And I had a lighter here somewhere. So all I do here is I place this on the deck, and I heat just the tip of the hot glue up a little bit, and I stick it onto that, and I have a test remote control button. And it looks reasonably okay if I peel the sides back so we don't have a lip on it. And I'll let that glue cool off for a minute, and we'll find 3 volts. Alright, so now we need some variable voltage on here. We're in current mode. I'm guessing that's a lot more than 3 volts. Let's switch on our variable output down here. It's at 10.2 volts, and my multimeter I've checked up too. The reason I'm going to have the multimeter is these don't read below about 4 or 5 volts. So we're going to wind this down. This was donated by the late and great Ken Anderson too, who also donated this, but you'll find that video later on. Let's go down to a little below 4, and we'll probably see down here that that display has gone out, but we have about 3.2 volts in here. I might dial it back just a little bit, just the tiniest bit, and 2.68 is a little low. Let's do this looking through the camera. About 2.98, that'll be good. Okay, that should be test voltage. Now let's get this set up. Okay, if this works, This will be the first time it's been heard in quite some time. Now I just want to double check my voltage first. Where are we? 2.97. Alright, multimeter can go away. Take that out of the way. I'm being extra careful here, so I'm sorry about the long cuts. I need a little bit of overhead light, so I'm going to use the microscope to do that. Okay. Now, we did establish that these batteries, the positive terminal is on the back. I looked these up. They are indeed 1.5 volt batteries. I'm just checking on the microscope here that they are. That is, the positive terminal is on the back, which means that's the positive, and the negative is down there. And I have negative onto a pad, positive onto the shield. I'm confident I have the polarity correct. Let's hook this up and hope we don't kill it. Okay, let's give it a test run. It works. Haha, give me a minute. I'm going to let this run through. I don't know if you can hear it. I'll do a better recording and I'll cut to that. Okay, here goes. Right, so I just played that for the wife and there were tears, so I'm not sure if that's a good or a bad thing. Anyway, we're going to go back to this bit here. Now, this is the back end of the microchip. We can sort of see through the fiberglass. I think that's about as well focused as I'm going to get it. But crucially, what this affords us the opportunity to do is to check in underneath the resin just along here, see if it's crept in on any of these tracks. I don't know if it has on this one, but it doesn't look like it's really done too bad. These have all been tinned copper, so I'm actually quite happy about that. And we can see that, I think there, oh no, hang on, this is our common ground line, and I think it does a hop and a skip over there. And our, no, that's our positive in there, that's our negative in there, so up here. So it looks alright. I'm not seeing any green corrosion under there. The sound output on this is quite stable. So yeah, owing to the fragile nature of this thing, I don't really want to put original batteries back in it. I think what we might do is find a CR232 battery holder and put that in there. And I've got them in abundance too. So I'll have a dig around and see what I can find. Okay, so next stage of the project. I'm going to sacrifice this Optus TV box. I got given about 6 or 7 of them quite some time ago. And I'm pretty sure this will have a CR2032 memory battery in it and a suitable battery holder. So we're going to pry this open and we're going to pull the battery holder out because I haven't got one spare. Now, because I have no specific love for these things, I literally just took the plastic facades and brute forced them off. And then I came up with some Torx tamper-proof screws, which tells me Optus was kind of worried about people getting into this, probably because Torx tamper-proof screws are cheaper than actual encryption. Oh, there's one central screw in the middle that's holding everything together. Ah, there's a plastic rivet. We'll pop that open. Okay, so the mystery screw was the warranty void if punctured seal. I am curious to see what's on the hard drive of these things and what format it's in, but Now that they're open, I don't see a memory battery anywhere. Maybe it's on the other side of the board. That's a shame. Just a quick side note, there was a standard SATA drive in here, and they really didn't want RF interference on the SATA line. All this big shielding and everything. Anyway, let's keep stripping this down. This is not what we're here for. Alright, so no memory battery on this. Guessing it was relying on being connected to, or listening in on the TV band where it can get a time sync. Oh no, here it is, here it is. That's it there. That's the battery and clock chip. It's got an inbuilt, yeah. So that might even be the battery there. Might be a rechargeable one, but that's our clock module. No, that's actually a network module. I was expecting a chip like that for the clock. Oh no, okay, so that's your gaseous surge arrestor, and that's an MOV. That's an opto-isolation block for the Ethernet. Yeah, this set doesn't seem to have any real-time clock. It's also got corrosion on the back of the board too. So, yeah, this is useless. Alright, let's find another board that has one. Alright, next candidate is a MyStar box, made by Thomson Telecom Australia. It's not often you see Australia written on things when they're electronic. Anyway, let's get this open. Maybe this will have a memory battery. If this doesn't, I'll be calling Tinkerman Mick. Well, this is one dusty as blazes MyStar box. And we've got this combined SATA IDE lead in here. But, crucially, I don't see a real-time clock module in here. Or a battery. Well, let's harvest a hard drive, and it's a 500 gig one, Seagate Pipeline. The other one was a 1 terabyte, and we'll rip all this out, and we'll salvage some usable bits out of this. Well, I had to pretty much pull the whole thing apart to get to the last 2 tamper screws for the drive. They really didn't want you getting into that drive, which probably tells me it's not encrypted. What is encrypted is this smart card that came with it, complete with smart card reader. So I might take that socket out and see if I can interface that with a Raspberry Pi or something in the near future. Okay, well, it's been a couple of days, and I had to wait to get some bits and pieces. Couldn't get hold of Tinkerman Mick, but luckily my local JCar shop had a CR232 battery holder and a battery. I also found a big hunk of foam that's out of a set of earmuffs I modified at one point. I've been tempted to put that back in there, but I think this is a more valuable project. I'm going to cut this up to use the foam to make the return spring for this, because I don't trust that little rubber bit. And then I'm going to put one of my remote control repair pads stuck onto that bit. So hopefully the whole thing should function. The first thing though, however, is to figure out how to get these cables out of this chamber, and I might need to do a little bit of modification here. And yes, I would normally put the original batteries back in here and just shove it back in, that'd be all good. But in this case, I want this to last for a number of years without having to be opened again, and this might be the way to go about it. So I've done some of the fiddly stuff off camera. The first thing I've done is route and change the direction of the cables here, allowing a bit of room for the cable path and also for the carbonized pad. Stuck a little bit of heat shrink on here just to keep everything neat, and I'll put heat shrink on this just to help prevent short circuits. I'm going to put the battery in shortly and test it. I've also reluctantly added a little slot in the side here so that the cables can come out, so that it will reassemble in that direction. And I did this, I asked first before modifying the original, just in case. And so now I'm going to take one of these little carbonized rubber pads, which I use for repairing remote controls. I'm going to take one of these guys and glue that into the little X in there, in place of the little green rubber pad that was already there. And then I'm going to cut some of this foam and put it around the outside. So let's get stuck into that. So I did the fiddly bit off screen. I've attached the carbon rubber pad in the middle there. Now I need to cut off an appropriate amount of foam and trim it down to size. Right, so we'll probably have way too much for this, but we'll see how we go. I need to probably, let's use this as a guide, and we'll trim around this bit to get a rough shape, and then we'll trim it down from there. We'll round it off a little bit, keep going around like this till we get enough to fit in there, and then I'll cut it in half. So I think we're getting to around about the same size. I think I'll cut it in half now. I'll get it to about the right thickness, and then we'll start to just trim down a little bit from here. I'm making a bit more mess than I would normally with a project like this, but this one, the sentimental value on this is extremely high. So, and given that we can't find this teddy bear listed anywhere, it's either worth nothing or worth a lot. I don't know. Now, I need to make a hole through the middle of this. I'm going to do a somewhat less than recommended method here. I'm going to use a soldering iron. Right. I have my fume extraction running at the moment. And even with that, it still stinks. So the next thing I need to do right away is tin this iron, which, let's move over here to where we can see me doing that, because otherwise the acids from that foam will eventually end up damaging the tip. So I'm using some flux cord solder to immediately clean the tip, and I'm using some Brillo pad in a cleaner over here. I should really put a copper one in there, but for the moment they're working alright. Alright, is my tip fairly clean again? Alright, so now we have a stinky bit of foam, but it sits in the middle there. So this will be a bit of a test. I better put the battery in this and test first. So, fresh new battery, let's double check our polarity. So, that was clearly the positive terminal, which is red, and red is going to the edge connecting, which is positive. Okay, I'm convinced that's the right polarity. If I can only get this thing in the slot. Okay, we're in. So now I should be able to just bridge two of these connections with just about anything. Alright, let's try the rubber pad. Okay, drop you on there. Okay, that's good. It's going to work. Now I need to reassemble it, which is going to be fun. I might need to take a notch out of this foam as well to accommodate for the wiring. Certainly louder than it used to be. I think the cleaning kind of helped. Make a notch for our wire here. Okay, line our notch up. Alright, that's going to drop in like that. Before I put that top ring on, I'm going to check that this triggers, but I've got to wait for it to finish first. We'll be back. Let's do this on the screen slightly, because I was off screen and didn't realise before. So we'll drop our cable into the supplied notch and position all this correctly if I can. That needs a slight twist. I'll see if this will function as intended. Put that in the slot there. Alright, let's try. No, it's not tall enough. Not making contact. Some slight adjustment is needed. So I made a minor change. I had a look at the depth of this little rubber thing. So I built up a little bit of hot glue here just to the height, similar to the original bit. And I think these bits here, the battery holders, were providing a bit of a standoff that was keeping it from touching that pad previously. Let's try again. Let's see if we can get this in the slot. Will it touch? Alright. Not quite there yet, apparently. Let's try it without the foam, see if it actually works. Haven't got the dexterity today to get that out without tweezers. Try this now. So it does when it gets down there. I need to thin the foam out perhaps. Or I need to make some removals. Yep. Okay. I'll do a bit of thinking, we'll be back. Right now I've cut 2 slots to accommodate the battery holders. And we will drop in like so. That works better. Now I can put this ring on, although I realised I need to put a notch in the outer ring as well to correspond with the cable outlet. So we'll do that and we'll be back. We have it assembled. Now, crucially, will it work? No. Something's not in the right position. Alright, I'll have to do a bit more thinking and disassemble it again. Trimmed the foam down even further, I've thinned it out and I've taken that chunk out. Let's assemble this and see if it works. Here goes nothing. Still a bit stiff. Keep trying. Disconnect the battery, the sound got a bit old. I think I've positioned the foam in such a way that will work now. Haha, success! Alright. Now I think I might pop the battery out of this again. I'm sick to death of hearing this song. Alright. Yep. Now the next trick might be to go and find some hand sewing needles, because I think I gave mine all away. But in any case, let's get this positioned back in the bear. The bear has a special pink bag, which you may have seen earlier in the video, that this is supposed to go in. The only way I can get the bag out is to compress the entire teddy, which I do so with great trepidation because I don't want to damage it, or the existing stitching that I've been so careful to preserve. Yep. Right, this is going to take a little bit of time and fiddling off camera where I'm less distracted by the camera. I don't want to mess this up. There's the original hole. Alright, we'll be back. So original sound module has been located where it should be, and he has had some surgery. He's got some electric testicles there or something. Anyway, let's push the button. It works. Awesome. I'm not living through 2 laps of this again, so we'll disconnect the battery a moment. This makes the battery change a lot less traumatic too. Now where there's already been stitching, that's where I'm going to situate the battery. It's going to sit down just below in here, just tucked in the genital area here, so anybody doing a gender test is going to feel something. So now all we need to do is find a sewing needle and some appropriately thick white thread, and I need to rearrange some of the original stitching here that I've cut as well. I've left as much intact as I could because it was grandmother's hand that did that. So yeah, let's get sewing. Alright, well I'm back and I outsourced the stitching job to the best professional I know. She did some fancy hidden stitching that I probably couldn't have done. But overall, it looks really good. I'm thinking it's going to go back to its original owner. But yes, 27 years since this teddy had a voice, and it does again. So yeah, it's all in all been a good night. We'll see you all in the next video.